with the total resistance equal to grade resistance and rolling resistance. We just mentioned rolling resistance in the previous video. Now let's work on the grade resistance. Grade resistance and effective grade. For the grade resistance, we also measure with the like rolling resistance factor grade. We also say grade resistance factor. And it also measures pound per ton of the equipment weight. And for that, it equal to 20 times grade in percent. Grade in percent. And same at rolling, we also have the grade resistance measured in pound. Grade resistance and measure in pound. And there can be two equations that we can have, depends on which measure we apply. The first one is equal to the vehicle weight, and for vehicle weight in the first equation it measured in ton, and then we time with the grade resistance factor, time with the grade that we just determined, grade resistance factor. Or it can also equal to, and for the grade resistance factor again, it measure in pound per ton, as determined in the previous equation there, 20 times grade percent. Or it can be equal to the vehicle weight and the vehicle weight in this case it measure in terms of pound, measure in pound, not ton in the previous one. And then we will time with the grade. With grade. So either way you will get the grade resistance. And from that we will have effective grade. Effective grade. And this basically help us to determine what is the travel time or variable time for the operation of equipment. So effective grade, it will be total resistance it equal to rolling resistance plus grade resistance. And that we already, this equation I just rewritten is already have here total resistance, grade resistance, and rolling resistance. But we want to know, okay, so combination of resistance due to rolling and resistance due to grade, what should be the effective grade in percent, so that I can easy to imagine what the resistance should be combining rolling and grade. So with that we can have the equation is straightforward. Effective grade after consider both rolling and grade resistance, it equal to grade percent, that is the geometry slope of the road that the equipment roll on, plus the rolling resistance factor that we determined earlier, resistance factor, and then we divide by 20. Divide that rolling resistance factor, divide by 20. And that we have rolling resistance factor here on the table for one that we talked earlier. So we can get the effective rate that consider both rolling resistance and gate resistance. Now, for the gate resistance, as you can see, for the gate resistance here, if it go up, then it's positive, and go down, it will be negative, right? So for gate here, I just make a note there so that for gate here, if you can see, if the go up, so will be positive, if go up. Okay, so it go uphill. If the rate here, it will be negative if it go down, if the equipment go down, and that basically reduce the total resistance. So in the next video, we will apply this for a problem 1.